All right, so in this video, we are going to be wrapping up chapter 1 by doing section 1.9. This will not be over 2 videos because there's only 2 little topics we need to cover. I'm going to talk about how to solve polynomial and rational inequalities. Now, rational inequalities is when you have a fraction involved with x's in the bottom. We'll get to that one second. The other one is the polynomial. We saw linear inequalities already, but what happens when factoring has to be involved with your inequality? We're going to look at how that works in an example in this video. So with both polynomial and rational inequalities, these do take kind of some pre-work to get done before you can actually answer the question. And so what I've done here is try to type out really the 4-step process that I go through when I'm solving these. And by all means, if you need to pause the video so you can write them all down before I explain them all, do that. But this is kind of how I keep myself structured in the process. So what I do first is I will take my expression and I'm going to set it equal to 0 and solve for x. Now, for rational expressions, you also have to figure out where the expression does not exist. We'll get into both these examples in just a few minutes. When you find these values, these are what's called boundary points. And boundary points is how you will divide up your interval in order to answer your final question. What I will do is I will take whatever those boundary points are and I'm going to put them on a number line, and then I'm going to pick test values that fall between each set of boundary points. So for example, if I had a boundary point of 1 and a boundary point of 4, I would need to find numbers on each side of those numbers. And we call those test values. Here's where your calculator will play a big role in this problem. You need to take the test values. I'm going to highlight this part. You're going to plug the test values into your original expression, and you are going to see if it gives you a positive or negative answer. The good news on step 3 is that the actual value does not matter. For example, if you get -4 or -100, that does not matter to us in these problems. All we care about is that it's a negative number. So what I would recommend you do is just get your calculator out, plug your test value into the original expression, and just see whether your calculator gives you a positive or a negative result. And then finally, after you've done all of this, you will use the original inequality given and the number line that you have just created to help you write your final answer in interval notation. And so this is the 4-step process that I always go through when I'm solving polynomial or rational inequalities. And so what I'm going to do in this short video is show you one example of each, because every problem, just like them, works almost the exact same way. So let's begin with an example of the polynomial inequality. So the one that I've picked out to work for this video is x squared minus x is greater than or equal to 6. Now, just like when we did quadratic equations back in section 1.4, you can't really do anything with this until you get a 0 on one side of the equation. So what I'm going to actually do first is a little bit of pre-work. I'm going to move this 6 over by subtracting so that I have x squared minus x minus 6 is greater than or equal to 0. So that's my new problem. So here's my 4-step process that I now do. Step number 1 is I like to find my boundary points. And so I do that by taking the expression on the left-hand side, and I'm going to set that equal to 0. Now, as we've learned in previous videos, we can solve an equation like this by factoring. So I am now going to factor this quadratic equation. So that's x and x. Remember, you need 2 numbers that multiply to get -6 and add to get -1. And so that should be -3 and +2. Like we learned in 1.4, you will now set both of these equal to 0. And so on the first one, if you add 3 to both sides, you get x equals 3. And on the second one, if you subtract 2 from both sides, you will get x equals -2. Those are your 2 boundary points. And I think that's the hardest part of the problem, is getting your boundary points correct, because everything else goes pretty quick in the process. All right. Step number 2, I will go to a number line. As you can see on my notes, I went ahead and put one on here as I knew I would need it. And I'm going to plot my 2 boundary points in numerical order. So obviously -2 is smaller, so it comes first, and then the 3. And then I'm going to now pick test values that fall in between and outside these numbers. So over here on the left, I need to pick a number that's less than -2. I usually keep it pretty easy. I'm going to do -3. I then need to pick a number between -2 and 3. When I can, I always pick 0. And then I also need to pick a number bigger than 3. So let's call that 4. And what you're going to do is you're going to get your calculator out at home, and you are going to take those 3 test values, and we are going to plug them into the original expression in this problem, which is the x squared minus x minus 6. And so just to save some time, use your calculator. I'm going to do it over here with me as well. I'm doing my calculator here. And once again, we don't care what the number is. We only care that if it is positive or negative. So if you plug -3 into your expression, you should end up getting give me 1 second, a positive number. So I'm just going to put a plus symbol there right now. If I plug 0 into the exact same thing, you should end up getting a negative answer. So I'm going to put a minus there. And then if you plug 4 in, you should end up also getting a positive answer. All right. Now you're going to look back, and I'm going to do this part in green. You are now going to look back at the original inequality, which says you need to be greater than or equal to 0. Now remember, for a number to be greater than 0, it has to be a positive number. Every number bigger than 0 is positive. And so if I look at my graph here, I notice that this side of -2 and this side of +3 are positive. Those are greater than 0. So I'm going to shade those in. Likewise, since there is an equal sign on my problem, I'm going to put a closed dot on both of those numbers, because that's what we've learned to do since earlier in this chapter. And now that I have my number line drawn and sketched in, we can now write the interval answer. So remember, we've seen this before. You've got 2 intervals shaded in with a big gap, so we know a union symbol's coming. That first interval starts at -infinity and goes to -2, but the -2 is going to get a bracket because of the closed circle. Union, we're going to start at 3, which also gets a bracket because of the closed circle. And since that second interval goes all the way to the right, it goes all the way to infinity. And this is your final answer. That is the answer to the original polynomial inequality that involved factoring. And so, yes, it is a little bit more detailed in this case, but if you work every factoring inequality just like this, you will get the right answer. Find the boundary points, plot the boundary points on the number line, pick out test values, figure out whether those give you positive or negative answers, match those to the original inequality, and then use that to help you write your final interval. The second kind of inequality in this section is called a rational inequality. And so as you can see in number 2, the difference is there's no factoring involved. Instead, you've got a fraction where there are x's in the top and there are x's in the bottom. So how would we go about solving a problem like this? Well, step number 1 is you still have got to find your boundary points. But here's how boundary points are found differently than in the factoring part. What you will do is you will take what is in the numerator and what is in the denominator, and you're going to set both of those equal to 0. So that would be x plus 3 is 0, and x minus 1 is 0. Let's solve both of those. I would subtract 3 from both sides of the first one to give me x equals negative 3. And on the second one, if I add 1 to both sides, you will get x equals positive 1. That's the big difference. That's your boundary points. So I'm going to go over here to my graph, and in order, so negative 3 comes first, 1 comes second. There's my boundary points. I now need to pick test values. So I'm going to pick a number that is less than negative 3. Let's make it easy. I'm going to pick negative 4. I'm going to pick a number between negative 3 and 1. Like I said, I like the number 0 whenever I can use it. And then I'm also going to pick a number that's bigger than 1. Let's call that 2. And you are going to plug those those 3 test values into the entire original expression. So you have to do the full fraction when you do this. But by all means, do it in your calculator, and that is perfectly fine with me. So if you were to plug negative 4 into this fraction, you would get a positive answer. Remember, I don't care what the number is, I just care that it's positive. If you were to plug 0 in, you would get a negative number, so I'll put a negative symbol. And if you were to plug in 2, you would get a positive number, so I'll put a plus. If I look back at the original inequality, so look right here, that is a less than or equal to 0. Well, as we know, any number less than 0 must be a negative number. So I'm going to use that to help me to know which region I need to shade in. So less than 0 would be negative, and my only negative region is here in the middle. Now here's the other tricky part of this one. You notice that there is an equal sign on the inequality. So that would normally mean you would put brackets or closed circles, but that will actually mess you up here, and here's why. Since the bottom of a fraction cannot be 0, and that is where one of your boundary points came from. I'm going to put a little star by this one. This boundary point cannot actually equal 0. We used it to help us divide up our interval, but it cannot be included with our equal sign. So at the x equals 1 value, I'm actually going to put an open circle there because I don't want the bottom to be 0. That would cause something not good to happen. Now, the negative 3 that came from setting the top equal to 0, there's no problem with that. The top of a fraction can be 0, and that's not something I have to worry about. So for my negative 3, I can put a closed circle. And now if I project this down and write it as an interval, my lowest number is negative 3. My biggest number is 1 from the shaded region. But the negative 3 is going to be a bracket because I can include it there, but the 1 is going to be a parentheses because I cannot include the 1, because if you were to plug 1 in, it makes the bottom of your fraction 0. And so your final answer here is going to be negative 3 to 1 with a bracket on the negative 3 and a parentheses on the 1. And that's how you will work rational inequalities. And so that wraps up my video for section 1.9. You'll have plenty of examples on your homework. That also finishes up chapter 1 for this course. The next set of videos will begin in chapter 2, and we'll move in and dive in some different stuff that we cover in algebra.